Hi guys, thank you for joining us today. My name is Luba, I'm event manager at Intellias, and glad you joined to this event, this webinar. I hope this information is going to be useful for you. And while the rest of participants are joining in, let's just talk about Intellias a bit. So interesting projects, international clients, global representation, that's what Intellias is about. And we create unique software solutions for more than 2 billion people in the world with the help of 2,500 experienced specialists on the board. I'm sorry for this noise. Hope it's going to be off soon. So yeah, I invite you to visit our career page, and who knows, maybe match will happen. Now, just a couple of technical issues. You can write your questions to the chat, and our speaker will answer them after the presentation during the Q&A session. And please mind, there will be 1 minute delay due to YouTube streaming rules. That's it. I guess we can start. I would like to introduce our speaker, Pavlo Chernovyy, Senior JavaScript Engineer at Intellias. Pavlo, glad to see you here, and the word is yours.
So I just unmuted. Hello, everybody. Thank you, Luba, for introduction. Nice to meet you here on my presentation about the effective design on server JavaScript. And let's move on to our agenda that we are going to talk about today. This presentation is about 2 sections that we're gonna discuss. It's problems that we met on a server side and the solutions we have on a server side to deal with such problems. This presentation will be structured as use case analysis with code snippets where we can find out the particular case which we can met on a server, which mean we can understand how it implemented in a code. So to be able to improve our skills in the future, improve code base that we are working with, and be able to have some abilities to separate layers, making proper architecture design to be able to solve problems regarding to the business needs. Also we have solutions, and according to those solutions, we will be able to fix those problems. Let's have a look on a step-by-step bullet points that we have here. So we know that typical problem that we have, it's layer separation. What I mean is when we have our NodeJS API that we wrote on some of popular frameworks. It could be Express, it could be Koa, it could be other frameworks or pure Node.js. We typically see the situation where our services, our endpoints, our router, our entity creation, our business domain, our database models that we have, everybody is in a communicated with each other, and it is a mess to be able find out quickly the problem area, to debug it, and to improve such things without breaking something, right? And it is increasing difficulty of support because of this first one issue. We have increasing difficulty of support. So it means that some of newcomer is going to have a task about making some adjustment in a code base. It it always difficult to support it quickly without extra help in terms to give enough quality for particular service. Lack of confidence to do changes. What it means, typical case where API based on Node.js were produced very quickly, no test involved, any tests like unit tests, end-to-end tests, no tests at all. And after some time, customer came to us with additional request, and it is pain to make modifications and evolve the business rules regarding to the entire concept, to keeping it stable without having those tests. And we will try to avoid such things, because it will be easier to make new endpoints, new services, etc., instead of dive into existing code and try to modify it without tests, right? So without tests, we like going into room with no window. So it is very very difficult to maintain such situation. Another problem is library-based and small test-oriented coding. It's about we will have the use case where we can particularly find out what is it about, and basically when we have a Node.js application, we import a lot of libraries from outside and rely on them, and we put them into our router, we put it into our services, and when we just want to test some functionality which was written by ourselves, we have a lot of dependencies. So for example, we depend on Axios, we depend on other libraries which make process to operate longer than we expect, and we cannot just simply test if our function behaves as we want it to be. After we discuss the problems, we will go to the solutions, and yeah, I think this is our agenda. Let's have a look into our first slide that we have. So I name it like single router problem case. Let's have a look. I prepared the same structure for each slides that we're gonna discuss. I just open it into browser window, and we'll modify the percentage of view. So we start from the beginning when we have some. Imagine that we have our application based on Express, right? So Express have Express have a typical notation about the app. So we have the app, we have routers like post, which mean we need to have a post request. And when the app is pretty much simple, so it looks awesome because we have the some entity in the request body. Somebody wants to submit it, and we just need to create it in our database. So imagine that this code is supposed to create it in the database and just respond it to the client. Pretty much simple. Moving forward, but I will clear the annotation. So after some time, our router became more much bigger, and it means that we have another entity here, user and to do. We need to create them both and respond the same result. But after that, we want to send some mail notification about the to do entity was created. Looks okay as well. Moving forward, and we see that our customer came to us and said that after we did such manipulation, we need as well to change the quantity of to do, and to have such ability, we just find our counter and modify the quantity, update it, and move forward. So right now we added ability to notify somebody through WebSocket. It could be user, it could be admin, and we added the try catch block. It means that we expect to have some errors from this, and we handled it in such way. So moving forward, at this point, our customer came to us and said that business rules changed a little bit, and we do not allow to submit some quantity of to do. For example, more than 5, we do not allow to make it, and we just need to respond that it is forbidden. And the other logic stays the same, but we see that our endpoint increases. And at this point, we have endpoint with additional rule, which says that if user is subscribed and his domain is supported, so we can proceed with sending email. If it's not, so we just skip it and adding the counter as we did before. And I used the open source tool for measuring metrics in VS Code regarding to complexity of such code regarding to modification it for the developer, for the human. So if the human sees on such code, this complexity is 7, it means that it's time to do something, because at each of these points, we waste some time to understand what happens here, what happens here, and we put every little bit of such behavior in our mind, and it slows down us to predict what happens where before we analyze the entire scope. Okay. Moving forward. Okay, here I made a couple of notions regarding why single router is a problem case. It increases difficulty to be understood by developer. Developers will avoid to make modification because of test absence. And of course, complexity for the mentality to be able to understand how it works, how it behaves. It requires some time to deal with such logic. Mixed responsibilities between system layers in one place. So we saw that it handles the error, it handles the validation, it handles the socket communication, which returns back the response from the mailing server, and also it handles updating the counter and maybe something else. It has another thing, which is bug and error occurrence is high. Try catch is interpreted as a solution. Yeah, bug occurrence is high because we didn't put try catch at the top to be able to cover entire flow. I would not say it is a solution for such application just to dealing with the error occurrence, but anyway, we just put it into the place where we thought it could be the problem area. And we rely on that try catch with expecting it as guarantee of server reliability. Okay, moving forward, another problem case is the smart function. Let me move it here. Open in the browser and back to here. Okay. Bit to page. It's okay. Let me be here. So, for example, we have another endpoint which says on some cart item we need to process our commercial shop, for example. And so at this endpoint, we need to do next things. We have a user. We want to find out cart for such user. We want to calculate totals based on such cart and to get price based on totals. We require somewhere at the top of such file those dependencies, which is cart, calculate totals, calculate prices, functions. They are not required at this point because they encapsulate calculation behavior, and we only need to pay attention to details within existing endpoint. And it returns the status 200 with actual price for that cart item. It looks okay because basically it looks like it's synchronous, even if those functions would be marked as async await, always the case. But it looks okay, understandable, and we can easily find out what could be a problem, and by even commenting some place without extra debugging or writing end-to-end tests. Moving forward, so let's have a look on the calculate price function. So we scoped let's say that we scope some behavior within those functions. So let's have a look into calculate price as a smart function problem case. So it is a problem case because at the router it looks okay, but within that smart function problems still exist. Let's have a look how it evolves. At the beginning, we just have simple condition, simple requirements that we have a totals, which could be array, and we need to go through each total, increment the price, and return that price, which is good. It's synchronized function. We can easily unit test it, and result is every time result is number if we pass correct parameters. After some time, our customer came to us and said that we need to put that price to some amount because it's a base price and it is how it is. So without extra manipulation, we just added a comment. It is a base price and probably will be changed in the next release, right? And so it is an anti-pattern, of course, but sometimes it can occur in the code bases. And also we just put it tax calculation because customer came to us and said that, you know, there is need to calculate price with the tax. That is why we just did not introduce any variables. We calculated within, and that's it. It just simply and not good solution. So simple and not good solution. So, and let's see how it involves later. After some time, we came back to such code, or other developer came back, and of course they do not have time to dive into what is base price, why it should be here. Okay, if it's here, then it is needed here, and I will not modify those things because maybe some places are rely on base price. And what I need to do, my task is supposed just to add one verification, which is if user has a first order. So if it is a first order, I need to add another calculation here, and that will be it. So task will be done, and nothing else should be changed, because, you know, no tests involved here. I'm not supposed to do refactoring here. I just need to introduce the feature, right? And having that in mind, let's have a look into drawback another that we have here, which is additional parameter user, right? So we had just the totals before, but we introduced user, we introduced another condition, another calculation, and we did not fix those things. So at this point, we do not understand how the business logic is working within such a little function. We just modify it and moving forward, get new task and forget about this. And such code continue to evolve in a bad way. Let's have a look how. So another time we came to this code again, and regarding to customer new requirement, we just put the comment which says no reason to have price, need to return items price if on sale. It means that we are doing the same calculations, so we did not omit them, right? So we're having those calculations here. We just put another condition, and regarding to this condition, our task behaves as we want it to be, right? So we can mark this ticket as done, and it even passes the test, right? It even passes the test on our staging. If we just smoke test it, it will be okay. But what we have here, we have additional parameter, right? And still code is not refactored, and we do not understand how it works, right? So we have no full covered business processing within such a little function yet. Okay, moving forward. So we find out that on our server, we faced with a random error, because some customer came to our customer, right, and said that price calculates with an error. So what we did, we just put try and catch block and some random message here, like error in place, and we expect that error will be logged here. Okay, moving forward. And another thing, besides those try catch block that we had with returning default 0 if such error behaves, we introduced another condition. So we introduced it at the top of a function block because it's pretty simple. We do not need to make any calculation if cart is empty. So if no items in the cart, just skip it. Just skip it and return 0. So at this point, we have for our additional. So we have 4 parameters. At the beginning, we had only 1. We had the complexity increased to 11. We still do not understand how it completely works. We do not understand why such comment exists. Maybe they are very important. And another thing, errors still could behave, still could exist, because this try catch block is not very informative. It just says it is +++, so error can be in here or in here or in here. We do not know exactly where it is, so it is very difficult to debug on a server. Okay, moving forward. So let's have a look into why smart function is a problem case and notions. So even though such function was used with a small router, which we saw at the beginning, it implements GotObject anti-pattern, right? GotObject mostly relates to object-oriented design paradigm, but it has the similarity that such function knows about every rule, every try catching, like error catching mechanism, makes useless responsibilities exist as a legacy. So we saw after some time, nobody wants to deal with the comments in the code, because when a developer came to codebase and want to find out the source of truth, he will redirect such comment to the customer. And in a way, such comment was structured. Is not always the solution for finding the proper agreement between actual implemented design and actual requirement, because only working code, tested code, could be the best requirement and could be the best friend for the developer, because everything is clear and no additional questions need to be added, and no need to slow down the work to find out what should be done here in such case where we have just comments and do not have exact understanding. So it is a bug place producer, and it is obviously difficult to debug and maintain because of complexity. Moving forward. Another problem case, TypeScript option. So let's say we have calculate price function from the previous example, but we named it like calculate price version 2. And we decided to solve our complexity in a way that we need to introduce TypeScript into there, right? So we expected that it could be a very easy solution because we do not need to write unit tests. We do not need to write refactoring. We do not need to deal with such strange behavior marked with just comments. And for some reason, we thought that TypeScript could solve the mystery of understanding how such code behaves for us and our friends in a team. So what we did, we put the typing into parameters. And let's have a look what TypeScript helped us to find out. It found out that we had a wrong property name, so we fixed it. Okay, found wrong iterable type. Good. Let's have a look on drawbacks. It adds extra return statement. Does not improve overall flow, and adds extra semantics. And by looking at this code, such tool says that complexity is 13. So it is bigger than we had previously. And it looks like benefit is not such fine for us as we expected it to be. Okay, moving forward. Let's have a look into Notion regarding why TypeScript option is a problem case. So let's say the disclaimer that if we involve TypeScript without refactoring, without unit testing, without actual understanding what the business logic is about, it does not solve the problem that we had. Okay, I put some notions here from the official TypeScript website. So those three are from there. TypeScript is a JavaScript with syntax for types. Okay, so it is a JavaScript, right? So potentially, if we make all those listed stuff about refactoring and unit tests, we can discuss about adding TypeScript because it is an add-on, right? It's not silver bullet. It is an add-on which require us to have previous steps made. TypeScript adds additional syntax to JavaScript, obviously, so because we need somehow to mark the types. And that could be the situation where we mixed logic, mixed types, and it doesn't work at all. So TypeScript code converts to JavaScript, right? So TypeScript only works as a static tool, right? And it cannot find out the bug in a runtime. So, for example, if we have a look into such case, we will find out that by transferring the JavaScript code into TypeScript, we made a small error, a small mistake. We forgot to put 0.5 to make the proper calculation. We just put 0, and for the TypeScript, this operation will be none, which means it is number. But for our user, it will be none, and it means that calculation for price of the product will be in a wrong way. So we will have the wrong value in our database, and we will have some problems with our accounting system, right? And of course, we can always expect a bug from this row, because it can be and this one this row can throw some exception based on a promise use case. But yeah, I agree. TypeScript will find out such behavior on a compilation stage, but this one will not be found out because our item price can be fetched, for example, from the database and from the other endpoint, and that JSON value can modify. And if we not add additional type to rely on, we can miss the proper calculation. Okay. So another last bullet point to the TypeScript option is about it doesn't deal with the code smells, just add types. This endpoint I added from my observation because I find out that the purpose of using TypeScript is about making the code typed, right? Not refactored, not tested, not improved, only typed. Let's have a look into one of solution that I put into such presentations that I think can be useful for us. It's about design our system with Uncle Bob architecture in mind. So let's have a look into Notion. Why Uncle Bob architecture is effective design case. So our bad case, which we saw previously, is this one. So when we deal with the data structure, when we deal with for example, with entity fetched from the database or entity calculated in a runtime, we need to realize what is it, right? So if we calculate something for our commercial shop or for our card system, we need to realize what is our entity that we need to make operations about. And we saw that couple properties it had. Base price, is it on sale, is it available, and sum price, totals, which user it is related for. So those properties are properties of such entity, right? And we need to form such entity to have a vision into what we are dealing with and expose it to our services, use case, and API. But in those problem examples, we did vice versa. So we had an entity which was within our core behavior. So we put entity in citation that it knows about service, use case, and API. So for example, what I mean by service, it can be, so let's say, let's have a look first of all on an API. API, it could be our router. Use case, it could be our flow that we want to calculate. So for example, we want to have calculation of our card item, and those procedures that we put into our router, we can mark as a one use case and name it as provide calculation for item. And the service is actual calculation stuff. So we had calculation of price, and that could be a function of that service. And having that in mind, we need to structure our entity in an encapsulated way. So each of such layer should know only about stuff which is working with. And the most important stuff should know nothing about outside world. The less important, so it should know only about the stuff which it is dealing with. So for example, if we calculate something, we proceed calculation stuff on an entity which has properties that we everything that we need for making such procedures. So we just need only to import our entity, and that's it. Our use case should know about the services. So we can import a mail service, we can import a user service, we can import a card service, and proceed some scenarios here. And API framework, it can be Express, it can be Nest, it can be Koa, it can be Happy. They deal with use cases, right? So we can say, so please provide calculation, and another use case which I don't care about working stuff within it at the moment that we have just router system. We just care about the payload we receive in our request body, and payload which we respond in a JSON format. And those use cases are responsible for dealing with the system. And that's it. Okay. At this slide, we have a solution case, entity service use case. Let's have a look. So code which we have here is about how we can structure previously made implementation in a good way regarding to slide according to the Uncle Bob's architecture design. So what we have here, we need to understand that we do not need to design our application from the endpoint as a starting point, because regarding to good way implementation, we need to start from the entity. After that involve service, use case, and after that, regarding to our needs and other technical stuff, we need to decide what framework we need to use, right? And it gives us ability to test it, encapsulate in an encapsulated way. So we can easily test entity, service, use case, and we tested everything with just unit tests and did not involve end-to-end test at this moment, right? And we can switch and decide whatever framework we want to use to cover our needs. It can be AWS Lambda, right? It can be some architecture solution based on the AWS Lambda, right? But it gives us flexibility because we have implemented stuff. We did testing. So we had everything and we are ready to decide what stuff we want to use to deploy it for our world, right? To show it for our customers. Okay, and for those reasons, I switched in another way the point that we are deciding where from we start to implement our application. And let's have a look into the first point. The first point can be function which introduce our entity. And for the sake of convenience, we can use function constructor, just simple lambda function which constructs the object with default parameters if we did not put any. And I prepared two tests with which can be which we can put tests in here. So for the convenience reasons, I just put it here to have a look that we can just implement such entity and have two important cases. It should make to do with default parameters and should make to do with custom payload. And let's cover it. So we import such make to do. It has default parameters. So first test is done, right? Another test, we just put our custom payload and verify it works. So done, we have an entity, right? And let's have a look into service, which supposed to operate with such entity. So we just create an object and decide what operations should be done with such entity. So we expect some payload from outside. It can be to do, right? It can be raw to do, which we got from the request body. And we will create actual to do with function constructor. And after that, we will put it into database. Pretty simple, right? So, and we can make it like that, like this one. We can make it in the object style. We can make it in a function style, which is also object because we export such functions into module.exports, and that becomes methods for the object. But let's have a look into simple one. So we just expect that to do. We can directly update our database through models, and we can write the couple of tests. So before each test, we can stop the to-do model because it is only the one requirement that we have at the top of our module. And it becomes very easy now because we can, by having that mock here, we can verify that methods of such to-do received parameters that we needed. And that's basically it, because we know that model is implemented within a mongoose, for example. And we do not need to test actual mongoose because mongoose is already tested. We just need to test that our parameters passing through our service will be put into those methods of mongoose, which we are mocking. And this is just similar way to express service with the function related stuff. We can also use classes, and we can make an entity directly within a service. And that's it. Let's move forward. After that, we have a use case, right? So use case means that we deal with the logic which encapsulate working with the services. So we receive some payload, we make a to-do based on our entity, we use the other services, and for the convenience, we agreed that we use array to respond status and data for each scenarios. Also covered it with unit test. And because of that, we achieved pretty much simple interface to get our payload, submit it, and respond. Okay. How many slides do I have more? Okay. So why entity service use case is a solution case? Code-based separation according to system layers. Easy way to maintain, extend code and fix issues, because we have fast feedback of system reliability by unit tests. So what I mean by that, we can just run tests and they will give us proper understanding what is going on with different payload, and pretty much everything regarding to the business rules will be covered. And we will be ready to move forward to the next step, dealing with top layers, which means framework systems, deployment stuff, etc. Understandable convention for team cooperation, right? So by introducing such a solution, we give our team to have easy way to deal with a difficult system. Okay. Another case, it's a library-based coding. Okay. Just a moment, opening it into the browser. So let's have a look into another case. At this moment, we start from the already known for us approach. We have a simple endpoint, and let's say we encapsulated important behavior into some function, right? For example, submit new user consultation. We pass a request user, and it's supposed to deal with the code in our own way. We just receive ID, status 201. Okay, let's have a look what can be wrong with such function. At the beginning, just let's have a look at the code. So it is a function, right? So we have it in some of our modules. We imported a couple of dependencies here. We imported a couple of services here. Function seems to be okay, right? So because we have only one parameter, we return understandable payload. It has pretty much understandable name and structured in a good way. But even the complexity is 6. It's time to do something, but it's not very complicated, right? So at the first time, it looks okay. So can be the case for our application. We can deal with it, somehow find out the bugs, fix them, and yeah, can be okay. But we are here to improve such functions because let's have a look into what can be the problem related to such approach. Such approach I called as a library-based development because we imported a lot of libraries. We imported them and use them within that one function, and we use direct database manipulation. We use some checking regarding to some time. After that, we use getting information from our prices API. We fill up the email template using the utility promisify function, and we're reading the file. So it can be the error because that file, that template could not be exist on the file system during the deployment. Also, it can be different, and the path can be changed. So each time path change, we need to make modifications within here. And also we deal with a link to S3 bucket. So let's have a look into logic, right? So we receive a user. We're supposed to create a consultation. We're supposed to get build query, check if it's built, right? So this code base is just my fake imagination of some use case, but it can be the stations that we need to deal with such behavior, right? So after that, we need to find out location that user is from, right? And for example, customer said that our application is supposed to send prices for proceeding with payment for such user, but only in the morning time. So we need to check is it the morning, and if it built, we just need to send a link to paid consultation. A lot of stuff here, right? So if we just say about what it does, right? it requires some time to explain what it does, how it does, and at each of this point can be the case that we need to make some modifications. So for example, customer came up to us and said, we need to make updates about sending notification to our users because we want to make it more regularly, and we need to put some modifications, or we need to fetch prices from three endpoints that we had, combine them, etc. Right? It can be a lot of complicated, and the worst scenarios that we have here is that we do not see the data structure that we operated here with. We just have a user and we have a build query. Build query is not data structure. It's not data structure. It's just a query that we need to put into the database and find out some result. For example, did it build, right? Did the user proceed with the build? And so besides that, we do not understand what the data structure is going on here, right? So because it's just a mess, because it operates with different systems, external system. So what should we do? We need to make such simple object in terms to find out what entities we want to create. So for example, user consultation assigned. How we do it, right? So we looking on this stuff and we try to form some entity which will be enough for us to form the data structure. So for example, if we have user consultation assigned, it needs to be a user consultation location and has built. So for example, we need to get such data before moving forward, right? And after that, it gives us ability to separate them, because if we find out the solution have to form entities with separation in mind, we will be able to differentiate them from this common place, and it will be good for us because we will be able to understand what is going on here and what entity it represents for the customer business. And the customer business says that we have user consultation site. For me as a customer, it is a user which has a consultation location, and we can check it if it was built. Admin billing notification. Admin billing notification is at this point because we need to notify admin about the billing, right? And to be able to do that, we need to provide an entity. It also need to have has built, user location, and consultation. Email consultation payment, right? So in terms to deal with sending user email for payment, we need to form the entity. So it should know, is it a morning, prices, email template, message, and price, one price for particular consultation. And if you deal with a payment like confirmed, you just need three properties: is morning, message, and link to paid consultation. Let's have a look how we can make methods which can produce such information. So to be able to produce such information like user consultation assigned, we just need to replace, to just add one word, right? Make user consultation assigned. So we receive user. We deal with the staff consultation location here. and we expose the data that we that we want to expose for later use. Okay, and for the same situation, we create make is user consultation build. We expose such information. Another function, another one, and we encapsulate utility-related stuff and send cancellation payment info within one function. Yes. Here we have another functions also regarding to email consultation payment, right? All those information should be as a contract exposed through object in a return statement. That is how we create an entity that we want to deal with. And it gives us ability to refactor the code that we had before, because complexity is for right now. We imported all of these functions from the outside service, which is consultation service. We passed the information needed to that as a bare minimum to that function, and other stuff that function should produce by its own, because we had a contract that said such function should follow object contract to be able expose the proper information outside. And we have a proper structure right now. Okay, moving forward to the presentation. Let's have a look into Notion. While library-based coding is a problem case, so it requires to boot up involved integrations locally to test the code flow. So imagine that we having those previous implementations wanted to just check if it works or if it not. We needed to have AWS booted up locally, right? We needed to have that template locally of the prices, right? And we need to put the breakpoints on each step to be able find out the bug if such occur, right? Because we need to follow each step of the if condition to find out what was wrong, if the only template missed or prices was wrong. So what is happening? Difficult to localize issue on production requires investment in tools. So it means that we need to provide some sort of monitoring system, which means we need to ask our client for time to involve such system on a server, and it requires time and qualification for those system to work properly, but their effect on our system will not be such effective as we could cover our own implementation with the proper data structure and the proper unit tests, because in such cases we control our system. And in the case before, some monitoring tool which could work or could not. So it breaks information expert pattern from the request pattern. So it means that our function knows about the stuff that it should not know, right? Because information expert supposed to deal with within own behavior, with own state, right? So if we had if we have module, so we have functions only related to some model. If we have object, we have methods related to such object, and we have some state, and we want only to be able to receive some information, operate with such information, and produce some result, which we achieve with solutions that we had at the end of having a look into that problem case, and does not give understanding of the data structure involved. So it only looks like behavior-driven development. So we have a look into code and we see the behavior, right? So it clearly show up the behavior of that particular use case, but we cannot say for sure what data are flowing through that behavior, what the template is responding, what the JSON API is responding, what is important for us, what is not, what the database of the prices, etc., right? So of the locations, and nothing of those are explicitly showed for us, so that we can operate not only with the behavior, but with the state introduced as a data structure. Okay, smoke test coding. It is our, I suppose, the last problem. Yes. Very good. So I named it as a smoke test coding because for me, it gives ability to just verify the code for some particular reason without testing each scenarios. So let's have a look. So let's have a look into here. That we have our endpoint, right? So we have our endpoint with submit new user consultation. We expect to submit the user and receive 201 status with ID within the data field. Okay, we send the post request. We receive the data and message success, status, etc. But let's have a look into such function. Imagine that such function was displayed on a previous slide, and we had a lot of conditions there, right? We had a condition related to if it has built, if it is morning, and so different conditions here, and we just test that endpoint, right? We put a test, and it just return our data. So it means that we maybe tested this behavior. Maybe we came to here, right? Maybe we came first of all, here and made additional request and sent some email, right? Maybe we had a luck and we tested else condition, but we do not know for sure because it only we cannot say it for sure because the payload that we are sending is only the user, but behavior that we have here is behavior that we are relating on the internal states that we have in external states that we have in a database or other APIs, right? So the behavior of such function can be very different, and it means that we can test it only as a smoke test if such endpoint at least did not broken at all, right? So it is not very useful solution for us. That is why we need to reorganize such function as was shown before, cover it with unit tests. After that, we can proceed with a postman. We can even automate postman behavior, but it is the same situation as we had with the TypeScript, right? So we should analyze what tool should we involve right now and what benefit can it add for us at this point of evolving our system. So let's have a look into Notion, why smoke test coding is a problem case. It covers a small percentage of business scenarios. It gives fake confirmations that the system works, right? Because we cannot test all the scenarios. Requires more time than the unit test to run the scenarios, because at least we need to provide the proper payload, boot up the system, right? If our system relies on other libraries or the systems, we need to boot up them locally as well. And that is why it is a problem. It has lacks flexibility to test the payload dynamically, right? So by having unit tests, we can mock everything and test for any different use cases we want with the different unit tests, with different payloads, right? And we can save such payload into JSON within the test folder for convenience reason for different use cases, and it will be useful. Okay. Let's have a look into summary. So solutions we use to omit problems on a server-side JavaScript. We need to provide structuring system with entity service use case, and after that, API. Add unit test along with adding new features, right? So we add new feature, which is data structure, behavior, operation on it. We cover it with unit test. We prepare it to the pull request, and we are ready to go. If we do it later, it means that we will have a problem with understanding of such code because we didn't cover it first time. How we could cover it next time? It will be impossible because we need to spend time on a new feature, on an already implemented feature, and the customer will not understand us. We need to add unit test in order to refactor the system. So for example, if we came to the some module and we want to make refactoring, typically we just need to follow Boy Scout rule. So if we came here once, it just okay. We can introduce some fix locally, and that's it, scoped enough to not expose additional problems. If we came back second time, third time, it is a good candidate to refactor such method, such object, because we will be working with such a model very, very often. And for refactoring, we need to cover the behavior with the unit test, understand the data structure which is flowing through the behavior. And it will be very easy to restructure the code in a good way, which will be understandable for everybody. So make functionality design by defining data structures. As we spoke about, we need to have a look what it does, what is bare minimum we need to have to produce a function that called like make something. So we can separate it, and it will have just bare minimum of parameters, and will introduce a convenient way to work into our system in a chain. Use unit test as a reliable mechanism to get ability make system refactoring, right? So it gives the fastest feedback, right? And it gives us ability to modify code without worrying what will be broken. So we are not worrying about breaking the code. We just considered ourselves on improving the code. And that is why it is a good practice to use all these described solutions to omit problems on the server-side JavaScript. Okay, thank you very much. So right now is the time for answering on your questions, because it is a Q&A session. And I have those questions in my messenger right now. So first question, how do you test the stability of your solutions on different platforms? Thank you very much for the question. So we need to understand that implemented solution by the developer became implemented on his local machine. So they have ability to test implemented stuff locally. So we have our model, which we can invoke through Node and pass to model, right? We can say it as our solution, and the platform which we want to deploy it to, right, is a situation where we already tested the core of our application, because our application is about the data, is about the behavior, our own behavior and our own data. When we deployed it to external system, we need to follow, so we need to switch the context from the development to the deployment. So for example, our system in deployment mode, and our system should be tested enough that we are moving such system from different vendors and it behaves same way, right? Because we write down codes once, tested, and it behaves same way in different frameworks and platforms, except of situations where our architecture is has specific use cases. So for example, when we have some integrations and our system works with input and within output within a middleware chain of some microservice world. For these reasons, it is also enough to encapsulate our implementation with tested behaviors locally, deploy it, and find out what problems can be there. If there is behavior problems of our system, we go back, find out it, fix it, implement the test. It will be robust enough to deploy it again because bug will be omitted. If it's a problem of the platform, so nothing can be done here, we need to dive into the platform specification, what happens there, but it is another story because our code base works okay. Okay, moving to the next question. What was the most replicated problem on server-side JS in your work routine? I suppose it was a problem related to calculations in a runtime. So the architecture was written and designed in a way that everything was calculated in the runtime, right? So in the same time we received the request, we tried to produce some value. And that was quite often problem because I was involved to project on a different stages. Some stages project was already built and some stages required some refactoring. Some stages required some additional implementation. And I met problems where such behavior introduced not only the difficulty to support, but difficulty to operate with for admin users with such system because entire system was blocked by procedures that was started and take some time before finish. And this situation in a Node.js world can be fixed by introducing appropriate architecture, right? Okay. Another question, are there any specificity in debugging process? Are there any specificity in debugging process? I would say for the convenience reasons, first of all, how we find out the bug, right? We find out the bug through the user response or through the login system. So we need to localize the problem. So we need to have a look into it, find out what is it about, what it says, because errors can be very little descriptive. And we need to find out what it says and where can it occur. After that, we can open up our editor and read the code that we think can be the place, right? Can be the place. Imagine that we are not working with that system. We did not work with that system previously, so we need to get familiar with the style and what and where is going back and forward, right? And for those reasons, we need to read the code, right? To find out some place where it can occur. After that, we need to try to reproduce the bug locally, to boot up the system with external tools, and put the breakpoints to find out what behaviors cause that issue of broken data structures or a broken behavior. So that gives us pretty much good understanding how we boot up the system, what the style guides, where the problem can be. Also, we find out how easily we can localize it, right? And after that, we can turn off the external system. We can, but before we can having that breakpoint on, we can practice with a different payload and different behavior to be sure that in a way that we want to introduce the fix, it works okay. After that, we can turn off everything, introduce the fix, and cover it with a bare unit test. So, for example, if you introduce some if statement, try to encapsulate such behavior in a function, and that if statement can, for example, return some flag. So you check in some property, and that returns true or false, right? And you can easily test it. So because it is your function, you do not need to test entire flow that you are introducing fix for. You just need to put little tests for your small function. And that is how the debug process of issue which occur on a server randomly, where you even not familiar with, can be localized and fixed.
Pavlo,
Okay.
thank you so much for this great presentation, for sharing all these knowledges. I'm sure that people got it really great and they will use it definitely like in a daily routine. And I think it's kind of, that's it for questions. We don't have any of them. So I just want to remind you guys that I will share the presentation you've seen today, tomorrow via email, and follow us for our next events. And so just thank you so much once more, Pavlo, for this great webinar. It was
Thank you.
priceless.